S is the sample space. That means these are the possible values we could get from an event. Maybe it's like a lottery, and you could win $1 or $2 or $3 or $4. You're going to win, and those are all the possible options. They give us a definition for how the probability of each event is calculated. Okay, that's the formula right there. This is the formula when x is either 1 or a 3. This is the formula for probability when x is either 2 or 4. So they're asking us to find the expected value of s. So the first thing we should probably do is calculate what k is. And we're going to be able to calculate what k is as soon as I can click something here. It won't let me. I don't know why. Let's try this button. There we go. Okay, so the probability, if we calculate the probability of 1 and add that to the probability of 2, so probability of 3 plus the probability of 4. Those are all the options, right? A 1, a 2, or a 3, or 4. Those should add up to be 1. Because if you add up all the probabilities of an event, it's 100%. It's going to be one of those 4. So the probability of 1 is calculated using this formula. It's that letter k that we don't know times 1. Because it's saying x is our event. We're plugging in 1 in for x into the formula, just like with function notation in algebra. The probability of 2, we have to use this formula over here. It's k times 2 minus 1. So in other words, it's k times 1 again. The probability of x equals 3 is k times 3. K times x, so k times 3. And the probability of 4, it's 4 minus 1 makes 3, so it's k times 3 here. So if you rearrange that, that's 1k plus 1k plus 3k plus 3k. So 1, 2, 5, that's 8k equals 1, or in other words, k equals 1/8. So we found the constant k. Now we can calculate the expected value. The expected value is found by taking each value and multiplying it by the probability of getting that value. Okay, so the expected value of x equals the probability of getting a 1. This is our formula, right? Oops. I mean, you could either point to the formula up here, or we already wrote it out over here. It's k times 1, but we just found out k is 1/8. So I'm going to simplify. K times 1 is just, so 1/8 times 1 is just 1/8. I'm not going to write out the times 1 here. The probability of x equals 2 is right here. K times 1, so it's another 1/8. The probability that x equals 3 is 3 times 1/8, so it's 3/8. And the probability that k equals 4, that's 1/8 times 3 again. Oops, I missed something here. Look, it's supposed to be 2 times the probability. It's supposed to be 3 times the probability. I missed the expected value part, so sorry about that. Just so, because I don't want to confuse anybody with messing up the formula. That's 1 times the probability of getting a 1. That's 2 times the probability of getting a 2. That's 3 times the probability of getting a 3. And then we add that to 4 times the probability of getting a 4, which is k times 3, or in other words, 3/8 again. Okay, so we're ready to finally calculate our expected value. So that's 1/8 plus 2/8 plus 9/8 plus 12/8. And if you add the numerators, 1 plus 2 makes 3, 3 plus 9 makes 12, 12 plus 12 makes 24, so that's 24/8. So it looks like the expected value is 3, because 24/8, that's the same thing as 3.